All right, so that's what happens. And then in initialization section here. All right. So we have Z-gas. That's why previously in the builder, I neglect when there is an option to use Z global, because in fact, we do not need Z global. We already have Z-gas here. Okay. And yeah, gas zone, no oil. Okay. And then we put molality, aqueous primary in, and then this is the component, and then this is the molality. And for the volume fraction, anorthite, calcite, and kaolinite, it's like this. All right, and then let's see what do we have here? If you're interested, okay, maybe we can, yeah. After you add mineral reaction in WinProp, you will generate some keywords actually in this .dat file. And maybe we can, yeah, discuss about this. Okay, log chem equil coefficients, right? It's a bit complicated. Okay, actually it might be complicated, but it is calculated with a fourth order polynomial in temperature. Okay, yeah, whatever, we can just follow what the CMG gives for us. And then N-rate react, do we have that? Maybe I can search it here. N-rate, and then react. I don't have that. Or maybe not here. If you're interested in, of course, we find Aquifer, right? Yeah, so Aquifer. Maybe I can explain this a little bit. So this keyword specifies that the aquifer is completely filled with water, Aquifer, right? It must be followed by on or off. If this keyword is not used or off is entered, okay, a small trace of hydrocarbon phase is always present in the aquifer. In fact, we allowed that to occur, to happen. All right, it actually helps us in the calculation. We allow a trace amount of hydrocarbon, methane actually, to exist, to be present in the aquifer. And then let's see, aqueous viscosity. All right, and then we use Castin. This is viscosity model for the aqueous phase. It must be followed by Castin for the Castin correlation in this case. And then maybe, do we have something called RF calc? Okay, so this is to specify computation of phase resistance factor caused by change in fluid porosity due to solid deposition or mineral precipitation, or or dissolution. All right, and then activity model. Okay, this is some keywords. Activity model B dot. Right now we can explain this here. So this is the activity model for the aqueous phase. It must be followed by a B dot or other options. Actually, there's no sophisticated explanation, by the way, based on the manual. So if you're interested, you can find it in internet what B dot is. All right, and then here, der chem equil. This is method for calculating the derivative of the chemical equilibrium equation. All right, it must be followed by either numerical or analytical. Okay, just like what we see in WinProp. Okay, so again, this is method for calculating the derivative of the chemical equilibrium condition. This one, der chem equil. Okay, but for their react rate, this is method for calculating the derivative of the mineral dissolution or precipitation rates. Okay, so this is actually to calculate the derivative of the rate. In this case, the line 136, this is the method to calculate the derivative, of the, chemical equilibrium condition. Okay, again, for 137, it must be followed by numerical or analytical. All right, and then why accurate cutoff? Okay, this is mineral dissolution or precipitation rate are set to 0 if the mole fraction of the gaseous component in the aqueous phase is less than this specified limit. Okay, this is what we set in WinProp. Okay, again, mineral dissolution or mineral precipitation rate will be set to 0 if the mole fraction of the gaseous component in the aqueous phase is less than the specified limit. Okay, if you're interested, you can go back to my WinProp video. I already, say or talk a little bit about that. And then salinity, if you're interested, let's see. We have salinity where, okay, salinity calc. All right, of course, calculation for salinity in molality. It must be followed by on or off. And then what else? I think that's pretty much all. Do we have reactive? Okay, reactive surface area. Right, this is initial reactive surface area in meter square per meter cube. All right. Okay, we already input the value in the WinProp. And then log TST rate constant. Okay, and then I think that's pretty much all. Of course, if you want to really understand, you need to go to the fundamental first, especially the fundamental of the mineral trapping, CO2 mineral trapping. And then you also need to check the manual, the guidance in CMG GEM for CO2 sequestration case. All right, so far so good. Now don't forget to save. And as I said before, we need to go back to Builder because we want to add something to be produced in the result. Okay, so let's go back to Launcher first.